Answer to homework 4, question 1. The question reads, find and draw the cumulative distribution function of y and the density function of y in terms of the distribution function of x and the density function of x. And so what was given is that y is equal to g of x, which is equal to 2 for all x less than 0. It's equal to 0 for when x ranges from 0 to 1. It's equal to negative x plus 1 for when x ranges from 1 to 2, and it's equal to negative 1 for when x is greater than 2. Okay, so if we draw that out, essentially it looks like this. So anytime x is less than 0, we have it equal to 2. When x is going from 0 to 1, it's just g of x is equal to 0. And then here we have a slope line, the negative x plus 1, up until it reaches 2, and then negative 1 for all x is greater than 2. Okay, so essentially y, or g of x, then ranges from negative 1 to 2 this way. So therefore, the cumulative distribution function of y is equal to 0 for when y is less than negative 1, and 1 when y is greater than 2. So essentially saying that there's 0 probability that y will ever be less than negative 1, and for when y is greater than 2, 2 is the max, so the area is equal to 1. So when y ranges from negative 1 to 2, we essentially calculate the probabilities at y equals negative 1, y equals 0, y equals 2, and y equals negative x plus 1. So when y is equal to negative 1, that's also equal to the probability of when x is greater than 2. Essentially what we're doing is we're switching the variables because we want to find the two distribution functions in terms of x. And so the probability of x being greater than 2 is equal to 1 minus fx of 2. And then for when y is equal to 0, we have probability of y equaling 0 is equal to the probability of x ranging from 0 to 1. So again, you just do your upper bound minus your lower bound. And then for when y is equal to 2, we have it's equal to the probability of when x is less than 0, so that's just fx of 0. And then here you rewrite x, basically solve for x in the y equals negative x plus 1, so then x is equal to 1 minus y. So the probability of y equaling negative x plus 1 is equal to the probability of x ranging from 1 to 2. And then we use our formula that the density function of x, the probability of x ranging from 1 to 2 is equal to the density function of x over the derivative of the function. And so the derivative of negative x plus 1 is negative 1. So essentially what we have here is, and we also have x equals 1 minus y. That's what we subbed in here. So we have fx of 1 minus y over, it's kind of hard to read, but it's the absolute value of negative 1, which is just fx of 1 minus y. And so then when we write that into the density function, we have when y equals negative 1, the function is equal to 1 minus fx of 2. When y ranges from negative 1 to 0, the function is equal to fx of 1 minus y. When y is equal to 0, the function goes from the function is equal to fx1 minus fx0. When y equals 2, the function is equal to fx0, and then in all other cases, it's equal to 0. And so then for the cumulative distribution, you have when y is less than negative 1. We're going to draw this out afterwards, but when y is less than negative 1, the function is equal to 0. When y ranges from negative 1 to 0, the function is equal to 1 minus fx of 1 minus y. And so the way to get these next two, actually, so we use this formula That's the cumulative distribution function of y is equal to the probability of the function being less than y, which is the same as the probability of g of x being less than y. And so if I sub in g of x, which was negative x plus 1, and this is when we're solving for when y ranges from negative 1 to 0. So between negative 1 and 0, y is equal to negative x plus 1. And so you start off with that, and you kind of start rearranging it. So negative x plus 1 is less than or equal to y. You could rewrite that as negative x is less than or equal to y minus 1. And then if you multiply that by negative 1, you change all the signs, but you also change the direction of your equality. So you have x is greater than or equal to 1 minus y. Or that's also the same as saying that this is the same as rewriting 1 minus probability of x being less than or equal to 1 minus y. And that right part of the equation, that's fx of 1 minus y. So that's essentially where the 1 minus fx of 1 minus y. And then for the next one, it's a little more intuitive. People can kind of see it from the graph, but you can still do it this way. So if I sub in, instead of having an minus x plus 1, I just sub in 0, and I essentially do the exact same thing over again, and you end up with being able to rewrite that as 1 minus fx 0. So that is what that's what the function is equal to when y ranges from 0 to 2. And then, like we said before, up here, sorry, where are we here? Yeah, so we already knew the 0 and the 1, so essentially we wrote that down here. So the function is equal to 1 when y is equal to or greater than 2. So when we draw that out, so for the density function, basically the density function is the derivative of the distribution function. So that means that the cumulative distribution function is the area under the curve. So the area when the function is, or sorry, the area when y is less than negative 1 is 1 minus fx of 2. The area from negative 1 to 0. So the area at y equals 0 is fx1 minus fx0, and then the area at y equals 2 is fx0. So the only curve we have is basically from negative 1 to 0, and that's essentially the distribution function of x between those 2 points, and so that's what we have drawn here. So you have the same curve here, and then everywhere else the area, so here are the areas that translate here, and so the areas are really just vertical lines at the other points, and then there's no area ranging from 0 to 2, because it just jumps from 0, and then there's a jump there to 2, which we kind of saw in the first graph, where there was just this jump here. Okay, so that's the density function, and then here we have the cumulative distribution function. And so, for example, here we have fx0 is kind of just arbitrary, so under here, since we know that anything past 2, that's an area of 1, down here we have an area of 1 minus fx of 0.